Welcome everyone. In this tutorial we will talk about the auto last hop setting that is available on F5 LTMs. Right, so we've got a VIP configured on one of our LTM boxes running on VM. And this is the setting that we are talking about, auto last hop. By default it is set to default, which means that it depends on what the VLAN setting is, which is also set to default, which in turn depends on the global setting, which is enabled. So by default, auto last hop setting is set to enabled on every new VIP that you create. So what this setting does is it captures the last recorded MAC address which was used to deliver the packets to the LTM, and then when it has to reply back to the client, it uses the same MAC address instead of using the routing table. So I'll show you that with the help of some packet captures. We've got a sample topology created in GNS3. We have the client, which is my laptop over here. This is the core. We've got several distribution layer switches. We are not using the GTM and info blocks and the firewalls, so you can ignore these two you can ignore these two service blocks. We've got one LTM configured over here, which is a standalone LTM. We're not using this in this example as well. This is the LTM that we're going to use to show you this example. So this LTM is running on VMware, and again it's a standalone LTM. And I've got the server farm running in this distribution layer service block, and we've got two CentOS HTTP Apache Web Servers running in this server farm. So I'll show you the basic LTM settings. It's got a default route pointing to the HSRP IP address between R9 and R10. It's got a self IP on external VLAN through which the connections are going to come in. We are running a single ARM model, so the same VLAN will be also used to send the traffic to the server farm. The VIP that we have created, we've done a snat setting so that the servers respond back to the LTM, and then the LTM sends the response back to the client. So we start a packet capture on this interface so that we can capture both client side and server side traffic. We can do a small filter over here as well to capture only the relevant traffic to us, which is going to be port 80. So the VIP configuration is pretty simple. I've configured an HTTP profile, a custom HTTP profile, so that no caching is used to display the response on the client browser. So what I've done is I've stripped off some headers like e-tag, which are used by the client browser to display the contents from the cache rather than actually hitting the web server. So in our case, all the requests sent by the web browser will be sent to the backend servers. There's another feature which I've set on the server farm, and that's your KeepAlive setting, which I've turned. I've basically enabled this KeepAlive setting on the CentOS servers. Now what this does is when you have a TCP connection coming in for a web page request, as soon as the content is delivered by the web server, it closes the TCP connection. So when we enable the KeepAlive, what happens is once the web page is delivered to the client, the web server does not close the TCP connection. So in our case, the client and so there will be a client side TCP connection between the client and the F5, and there will be another TCP connection from the F5 to the server. So when we turn on KeepAlive, what happens is that once the web page is delivered to the client, both the connections are still open, they are not closed, and I've set a timeout of 300 seconds. So in 300 the connection is not going to time out in 300 in 300 seconds. So if the client does a refresh or tries to fetch another web page, the get requests will be sent on the same TCP connection. No new TCP connections will be formed. Other than that, the VIP settings are pretty standard. We've configured SNAT so that the server response is sent back to the LTM, since we are doing 1-hour model. And yeah, and the pool member settings are left to default, no changes over there. Okay, so let's make a connection to the web. That's the web IP configured on port 80. Okay, so the web page loads up. Let's check the capture over here. So we see that the source port used by my browser is 63194. We can verify that using netstat. Yeah, 63194 is the port. So this packet, basically, this is the first get message that was sent by the browser to the LTM web. We can see the MAC address that was used to deliver the connection to the LTM. So this is the MAC address. Let's check whether it's R9 or R10. So it's not R9, so it should be R10 then in that case. Yeah, so this matches. So we've got the connection coming in from the client to R1 and from R1 to R10, and then delivered to the LTM using the MAC address of the Ethernet interface of R10. Okay, so let's just quickly verify if our connection is still open. Yep, it is. We can do another get as well, or rather just refresh the connection. And it should be sent using the same TCP connection. Let's verify that as well. Yeah, so another get without a new TCP connection. There is no sense in act after this initial get, and we can see that it's the same TCP connection again. All right, so I'll show you the response from the LTM to the client, and we'll see what was the destination MAC used by the LTM. So the connection was sent from the LTM to the backend server. The server responds in this frame, and the LTM VIP responds back to the client. 1050.53 is the IP address of my client. And let's see the destination MAC, which is exactly same as the source MAC that was used to deliver the connection from the client to LTM. So this is the R10's Ethernet MAC address. Alright, so if we shut down this interface, what happens then is R9 of course becomes the primary HSRP router, and the LTM should be able to send the response back using R9. However, it tries to deliver the packet, or it tries to send the response to R10's MAC address, which is no longer available, and the connection then drops. and of course your browser is going to make a new TCP connection which will be coming in through R9, and of course the client the LTM will respond back to the client using R9. So in cases where you have your upstream routers or devices or firewalls running a redundancy protocol like VRRP or HSRP, and if you want that the connections should not time out because of a failure, then you should think of disabling the auto last stop feature. So let's just again verify if the connection is still open. It is indeed. Let's now shut down the R10 interface. So we've shut down this link over here, and if we now do a get, it's going to fail. And of course, after a while, your browser set up a new TCP connection, and we shall verify that. Let's first check the port. It's a different port now. Let's check the packet captures and see what went wrong over here. So we have the last get which came in from my client to the LTM on 63194, which was the old TCP connection. The LTM sends the connection back to the server. Server responds, and the LTM is trying to send the packet back to R10's MAC address, which is no longer available. So this packet never made back to the client, and hence you see that the client is now trying to do some TCP retransmissions. So you can see a few TCP retransmissions from my client to the LTM. Of course, none of the response made it back to the client, as you can see that the LTM is still trying to send the packet back to R10's MAC address instead of using its routing table. So of course the client is sitting on a remote subnet. The LTM has got a default route which is pointing to the HSRP IP address and of course the corresponding virtual MAC, but it does not use that. It instead used the MAC address that sent the connection originally, and then of course the connection times out. The client sends a reset to the LTM and then opens up a new TCP connection which is on 63323 this time, and we can see that this connection was eventually successful and the page loaded up on the browser. Now let's bring the interface back up. And let's shut down, or rather disable, the auto last stop setting, and then let's observe the behavior once again. So we'll disable auto last stop. Alright, done. And okay, let's in fact shut, or rather delete, this existing connection that we have. Okay, let's verify that if we have no more open connections. There we go. So no open connections now. Let's make a connection to the VIP once again. Right, let's verify the port. It's 63403. Let's observe our packet capture. Yeah, it's 63403. This is of course the initial SYN sent from the laptop to from the client to the LTM, and it shows that the source address was again the R10 Ethernet interface. Let's see the response back from the LTM to the client. The destination now is the virtual MAC associated to the HSRP IP address. It's not R10's Ethernet interface anymore. So indeed, the LTM used its routing table instead of recording the last MAC address. Now, if we shut down the R10 Ethernet interface once again, the connections should not drop this time. Let's verify if the connection is still on, and then let's do a refresh on this connection. And I think it did not fail this time because there was no latency at all. Let's verify in our packet capture. So this is the GET that was issued by the client. Again, it's on the same port, same session, 63403, and we can see that the response back from the LTM to the client is going to the virtual MAC associated with HSRP rather than R10's Ethernet interface. Right, so thanks everyone for watching, and I hope this was informative for you.